Okay, so this is Jun from Microsoft, and there's typos somehow in the in that big screen. Actually, I will talk a little bit about how Microsoft built it for MySQL, PostgreSQL, which already GA is last month, and also the MariaDB, which we announced a couple months ago, but we still didn't get to the public yet. So first of all, as we are Microsoft, everybody knows we have a wonderful database engine called SQL Server. And then we also already built the SQL Server for Azure, which is running for a couple of years already. So definitely, we will leverage those assets to build our MySQL service, Postgres service, and the MariaDB service. We try to share lots of the commonality, especially around the operational readiness, all those common problem which for a cloud service. So here is talk a little bit about from the 1,000 feet above to see how the service looks like. So first of all, we share the hardware, like the cluster, with a SQL Server for all the service we just talked about. We have a single the infrastructure which contains everybody, including SQL, MySQL, PG, MariaDB, everything. So from this of the architecture, this set of things is every region will have this set of things and this big box. So every region have that. So far we have over 30 regions, 32 I think. 32 regions, we have this of the box. So if we look at the details inside this big box, this can be the 1,000 of the machines. And we will group them into two big buckets. One is called the control plane, and the one is called data plane. We will get to some details later. But basically here is what control plane means from the wording. You can think about all this of the provisioning, management, and the monitoring, all the failovers, all those we call the control things will be happening here. And basically it's provided some services like this to provide the feature I just described. And majority of the machines is really hosting the database engine. And here we call it the data plane. Why the data plane means? Because customer access this nodes from your data connection. For SQL Server, we use a TDS protocol. For MySQL, use MySQL protocol, and the PG has its own. So basically, this is all about operating your data. So this is why we call the data plane. Inside this data plane, the machines, there's lots of machines here. And for every machine, this box here shows on every machine what we have. There's three big buckets here. Is some port sharing service, which makes sure the TCP port can be shared by the multiple database engine services. And we have the resource governance service, which makes sure every instance inside this particular node can really share the CPU, memory, disk, all those things, guarantee the fairness. And also there's some sort of the healthy or monitoring sort of things which will be here. And this is three big, we call it a service. But later on, we will explain why we call it a service. Then you have all this of the MySQL engine things, which running as a separate process. Yeah, let's explain later on what exactly the process means. It's more complicated than a Windows or any normal OS process. So then later on, we also have our storage, which is very common, the decoupled from your compute. So this storage is not really built by the database group. It's more built by the storage group. I think this is the beauty of these things is you have a dedicated team. They are specialized on how solving the storage problem. And that's what we can leverage to shorten our time to market. So let's coming from the 1,000 feet to 100 feet to see what's really going on. This is a lot of the very small character there. Basically, this try to say how we actually sharing this sort of things. And you can see for every different database engine, the engine itself is different. But there's a very big commonality. We abstract as a database service platform, which do lots of things in common. Let's give you some interesting thing. Here is workload insight, which is a very famous feature for the SQL Server. We try to say, get some AI or get some intelligence to look at your workload. And we are trying to get this sort of things into the MySQL and the PG as well. But that's not yet available, but that's a beauty of we try to share this sort of things. And there's other things which is also very interesting is like the security and the compliance. That's Microsoft put a lot of emphasis, says, let's make sure our platform is compliant with lots of the standards, regulations. That's take a lot of effort. So because we share this, we can really bring this enterprise sort of the regulation or compliance to the MySQL and the PostgreSQL. So this is not commonly available in the industry today. And there's another things underneath we call Service Fabric. This is a big product coming from the outer side of the database group, which is try to solving the problem of the microservice. So in the open source world, this is commonly we choose Kubernetes as an infrastructure. But for Microsoft, we have its own implementation, which actually started before the Kubernetes actually happened. So it's already built for a couple of years. So for this platform, which solving all the hard problem like the distributed system, you normally need solving. Give you one particular example. When we're doing this sort of the failover high availability system, one of the challenges is how we can do very good hard beating. We don't want to lose the hard beating, and we want to make sure even the CPU is 100%, the hard beat still goes between these nodes. This is not that simple as I just described. So the Service Fabric team actually made a couple of the heavy lifted things. They end up to the solution is, hey guys, well, I have to write some Windows kernel driver, really do this sort of the hard beating to make it really reliable. I want to talk with my thread scheduler to say, okay, this thread is actually very, very important. You cannot delay my scheduling. Some of the problem, they actually help the solving here. And underneath, this is very common, like the Azure's infrastructure. One thing we already talked about is the storage, which keep lots of the state inside the storage. And definitely, you still have the networking. And also, how the VM things, this all things will be hosted in the VM, and this is what the compute team is provide us. And the monitoring as well. And also, this sort of things is applied to worldwide, globally. Okay, so let's get in a little bit more talking about this microservice. I already get touch with some of the basis, but why I want to talk a little bit more, because the whole architecture is being grouped or organized by the Service Fabric, which basically means Service Fabric is my really platform to organize my service. So the Service Fabric itself is built to try to solving the distributed systems problem. And here is what our service or this sort of the database service is try to leverage is we have to solving our scalability problem. We are not talking about to use 10 machine or 100 machine. We are talking about how we leverage 1,000 machine in one data center. When this number really increase, the complexity and also the problems, how hard the problem is also increased tremendously. So that's why we try to look at this Service Fabric, which is proven to be used in massive scale appliance inside Microsoft and also some cases outside of Microsoft. One is the interesting thing here is we try to say each database engine is a microservice, which doesn't sound it's very intuition, right? So database engine is a complicated part, but we try to treat it as a microservice so we can manage that, which means if the database engine fails, the Service Fabric will make sure this sort of the engine will be start somewhere. And this service also makes sure these two instances will not be alive in the same time. Otherwise, they will write to the same disk, which corrupts the data. Those things is be able to handle it by other way, but Service Fabric handled by much nicer way and much like the algorithm proven this sort of things. So that's why we leverage this. So okay, so we have all the basis. Let's talk about the real thing. So first is how we organize this sort of the 1,000 machines. I already mentioned that there's a control plane and a data plane. Let me say that again. Control plane for all the operations, provisioning, monitoring, all those things. And the data plane, which hosting all the machines really doing the real work. So here we say, okay, there's two clusters, basically. One is a control plane cluster. We call it a control ring. Why we call it a ring? Because, Service Fabric really groups the nodes inside the ring. Why this is a ring? Because this is set of the distribute system. They try to leverage this ring to make sure the high availability. I would not expand too much on why they use it a ring. Basically, you can think about use some DHT algorithm to make sure that each node be able to like each node, once a node fails, the neighborhood of this node can really solving the task original assigned to this node. So this is basically what they call the ring. So all the machines inside the two clusters, I just mentioned the control plane and data plane, into two big rings. Or technically, it's more than two rings. But control plane is one ring. And the data plane is multiple rings. Because the tenant is too many nodes. And sometimes we want to not having a super big ring. So here is we basically says our nodes, our machines is grouped by the service fabric as a couple of the rings. And the control plane had one ring, and data plane had another ring. So this is what the control plane really looks like. So inside the control plane, we have a set of the management service. As I just mentioned, this sort of the management service is really solving the problem of the operation. So think about it this way. Every operation you're doing from the website portal says, OK, Microsoft, give me a node. Give me a database instance. This will talk to this management service eventually. And this management service will persistence all the data into a database, and which sending some command to the data plane says, give me a node. But let's talk about it later. So besides that, there's one important thing we call the connection redirector. So why here is when we get an instance from the Azure, you get a DNS name, which says where your services really are. But this is actually not the node which is running your service. So in order to have the failover or the sort of the high availability, you have some sort of the redirector or proxy in front. So this service is really about that. This service is just sitting as a front door, says, OK, connect to me. Your DNS always point to me. And when you connect, I will find who is really running your service and redirect to that. And for MySQL, unfortunately, we don't have the redirector support today. And we are working with some community to adding this sort of support. So today, we cannot do the redirect. We just do the proxy. We just proxy all the traffic to the real node. In case of the fail, the front node will get notified by the service fabric. Says, oh, there's something bad happened. This actually the hosting your database engine's node is changed from A to B, and the port may be even changed. But the front door will automatically redirect your traffic into another node. So hopefully this sort of things will be noticed by your application. Your application just notice some connection disconnected, and when you try to connect again, then automatically everything just works. So this is sort of the control plane's responsibility. Handle the operation and doing this sort of the front door of the failover. So this is most the important part is we having our data plane. So as we already mentioned a couple of times, the data plane is a ring, and we have many rings in one region in order to slice the nodes into a couple of the groups. And for if we let's look at one of the particular node. There's a lot of we call the application services. You can think about this should be called database services. Is more database engine instance would be better term, but it's come to as application services. So all the SQL Server, MySQL or PostgreSQL, all those things is like a process, like something running as a service here. And of course, there's some platform services, like we just mentioned, like about the port sharing service, and the resource governance service, and the telemetry service. This is all we call the platform service. So platform service is a fixed number in one particular node. But for the application service, as far as this node can hold up, like some nodes can hold up like the 20, some up maybe hold at 50 instances we packed into the one node. So which give you the flexibility of your resource. And as we already mentioned, that all the data is be decoupled to the storage. So the storage maybe have the database file and also the log file. So that's what it looks like. So pretty much we use like the commodity like the MySQL or PostgreSQL to in here. But let's find an interesting problem. I can understand some people will have a concern. Hey, Microsoft, are you doing some really, really bad things here? Why you keep different people's stuff inside the one node and what's the isolation there? So yeah, I bet somebody already tried to ask the question. So here we introduce some sort of the guarantee. We say that the multi-tenancy ready, like the multi-tenancy hosting, which basically says how we can technically host the multiple, like the people's workload inside one box. So this is not a brand new problem. And this problem actually be asked like 20 years ago when we actually having this sort of things called a VM. At the time we says, okay, I have a physical node, but I try to put multiple workload or even multiple people's workload inside one host physical machine. And in the cloud world, this is called IaaS. The most of the VM things inside in today's Azure, or I bet every cloud every cloud vendor. So we basically say that every customer's VM we mix with other people's VM. So we have to provide some sort of the guarantee. And this guarantee is first is security. I have to provide enough security among this different instance. And also there's some sort of the problem you have to solving, like a noisy neighborhood. You don't want when another guy in the same node doing the stress testing and your performance really sucks. But sometimes you do notice that. And so this is basically the problem space. So let's look at, there's a couple of ways to doing that. So if ultimately you want the best guarantee, you use a different physical node. They share nothing. Or maybe they share some single PDU, the power adapter. But most time you can use this as a most stronger guarantee. And then you move slowly to the VM, and this is what today we get from the most cloud provider. And then we say, okay, how we get some container thing? That's a container thing, which basically says inside the container we have set of the Linux running. Seems like they are really decoupled, but let's discuss that, why this is not the best option. Then maybe the last one is, which is also possible, is I use a process as isolation. Let's talk a little bit about the process isolation. I already start from here, but let's talk about this first. So why we don't like the process isolation? So first of all, the process always assume everybody is a good party. And inside the one OS boundary, everybody is good. Like the database engine, everybody should not doing any stress testing. So that is basically the assumption. If you do stress testing, your paging file maybe be impacted, then everybody get impacted. This sort of things is very, very hard to avoid. Okay, we say, okay, maybe process sharing doesn't work really for multiple person, like multi-tenancy. Then we say, okay, how about the OS sharing? The OS sharing is basically says how much you want to share between the OSs. There's like the Docker container, which basically share the OS part of the user mode. They don't share the kernel part. And is this good? I think, yeah, sometimes, some degree, it's reasonable for certain applications or appliances. But Microsoft choose another direction. We say, okay, how about we running a stripped down version of the latest Windows in a security container, which is part of the user mode, part of the kernel mode. That's the answer to answer the multi-tenancy problem. So I will have another slide which talk a little bit about the details. But basically, I want to say for this sort of the technology, it's some degree it's close to the user mode Linux, some degree, but it's not exactly, and which provided a very strong security isolation. Basically, you don't share any security context between your container versus your host OS. So there's no sharing at all. And there's much stronger resource isolation compared to your other like the process things, because you probably don't share the paging file anymore, and you don't have a lot of the contention point for the resource. I would not say we 100% solving the noisy neighbor, but pretty much, if you do the stress testing in one database engine, probably you will not get noticed by your neighbor. And this, compared to the VM, one good thing is we can push more database engines into one node because the footprint is less. And also there's a reduced attack surface because this version is really stripped down. For example, because we don't use the web server, we don't have the HTTP.sys, which don't open any porting to the internet. All those is stripped down to try to reduce the attack surface. Last is a very interesting thing I will talk a little bit later on is how we leverage the MySQL server's assets. One of the interesting things is operation system from day one, they try to be very, very generic. It's not about I run database or I run Word, Office. So they are still single OS. Everybody is using today is Linux, Windows, or some other operation system. But SQL Server in the very beginning, when the SQL Server is building or even today's MySQL, if you're looking at the DBaaS implementation, we have a lot of the primitive is re-implemented from scratch just for the database engine. SQL Server doing the same thing. And if you really dig out to the details, say, hey, why you guys do some duplicate work? There's some interesting point there. Because general OS operation system didn't optimize for the engine, didn't optimize for the scenario, which database expectation for the operation system. Since we already like the running something different than the normal Windows, and we have a chance we can push this sort of things. Two things which is I want to call out is one is the memory management. So for today, the OS operation, like doing the memory management is very, very optimized for the lots of the small allocations and do solve how you map the exe file, loading DL, this sort of things is main target for the operation system try to optimize for. They are not really optimized for for the MySQL, I allocate a bunch of the memory and I just do my own algorithm to just fit inside that. But those things is not really NUMA friendly. For example, the MySQL don't have this sort of the consideration when they're doing the allocation. But OS normally do have that. But how we bridge them? So this is one of the interesting points we can leveraging by using the SQL things. And also, SQL Server has its own scheduler. In the normal operation system, all the scheduler is talking about, hey, how I make my mouse move so smooth. Or they're talking about, says, okay, how I can get my, the batch mode of how I detect this application is running in the batch mode, another application is running interactive mode, and doing the different scheduling. But this is not really database care. Database is more care about the fairness of your thread scheduling. When connection come in, they are doing something inside its own threads, which is still true for SQL Server, for MySQL, and one connection just doing all the work for your query. So we will try to make this sort of very, very fair. But this sort of things is not really available in today's operation system. So that's why there's some benefit there. I think I already covered this part. And let's take a little bit more close look at what this sort of I describe a lot of beauty of the SQL Pal, but how that thing really looks like. So this is our traditional OS, which is a Windows kernel. And then we write a small piece of the software here, which try to interpret some call from this of the user mode OS into the real kernel, to make sure that don't break the rules, which we basically says. And there's a bridge between this sort of things. Is we have some sort of the OS. Why is it called SOS, which means SQL OS? And some sort of the compatibility layer for the Windows, because in MySQL today still assumes that underneath is a Windows. So we still have some Win32 compatible things, and we put in this all things called as a SQL Pal. And give you some example how this sort of things works. So for example, like the MySQL says, okay, let me open a table x.fim, which I try to read the metadata. So this goes through the Win32 API because this is a file open basically. And this go to the libOS see, okay, this is a file open operation. I don't have a NTFS or file system inside my libOS, inside here. I just say, talk to this extension, says, okay, this guy need to open FIM file. Can you help me do that? This guy says, okay, I see what you want to ask, but I don't know if I should allow you to doing that. I will delegate this request back to here, says, okay, can you help me check if this guy really have the security context to open this file? After this check is valid, it will return back to the host extension, says, okay, I approve that. Then this host extension delegates this to the Windows kernel, says, okay, Windows kernel, this guy is proven that he can open this file, and this file is under his security context. All those things just go there. Then next, DBMF says, like the MySQL in the DB says, okay, I want to read this FIM file. Go read that. Since we already have the handle, this sort of things will be very, very performant because it's go down to the kernel directly. And there will not go something like that because when you open the file, we assume that it's read or write, it's just a work as it is. So that's a combination of the trade-off between the security, isolation, and also some performance-related thinking. So this is how the SQL Pal thing works. By the way, this SQL Pal thing is not like coming from recently. It's actually based on the MSR Cambridge, the original work on the drawbridge. If you search the drawbridge in the internet, you will find some papers around this of the security container. Basically, the paper says rethink about the software stack. So this is one of the work inherited from there. So we talked a little bit about the decouple compute and the storage, but I want to explain a little more details here. So we're talking about the remote storage is building by the dedicated storage team in the Azure, which their goal is having the community hardware, and which basically means we don't have very the high-end hardware which can speed up things like the Fusion I/O card, so we don't have that, but we continuously try to innovate around the community hardware, like recently the SSD or non-volatile memory, all those things, which see how we can improve this storage. But the good side is my team don't need to look at that. There's some dedicated team is helping me looking at all those things. But what my team is doing is we try to optimize the I/O. So inside the database engine, we always assume the disk is local attached. This is truly true for many, many years. But now when we move to cloud, decouple this compute and the storage is very common. So one of the way we have to do is we need to build some adapter layer to bridge this expectation mismatch. Because from the database perspective, I want, one of the assumption always is, if I write like the 16K data versus I run to 1 megabytes data, this writing 1 megabytes is far slower than writing a 16K. So because that's a basically linear scale thing. But in the remote storage, this is not true. At least in the Azure, this is not true. Because when you write a small amount of data, the latency is dominant all the time you spend across the network, go through their stack, and actually hit to the disk. So this time period is relatively constant across like the different size of the writes. So this sort of the things have to build some adapter in the between to bridge this sort of the mismatch. So we did something like the log file. It's always expected the low latency writes, and where we do the crash recover, this will be very sequential read. So we optimize the same things for this sort of the pattern. This pattern, I think, is pretty generic for every database engine. What particularly I'm writing here is for MySQL, but I think it's applied to PG as well. And for the data file, you require the high throughput, and but lots of the random reader and writes. And sometimes those reader writes is very small, and then we try to see, if I really see a very small reads, I will try to enlarge this a little bit. Even this didn't give me any benefit, but at least this sort of the reader I had, normally we don't do in the local disk, but we will do the remote storage because read more don't really give me the more time or more cost. So this sort of the optimization is what my team is doing. And last thing is, so we're really looking at the snapshot-based backup. So inside the recently involvement of the file system, lots of the file system is support the snapshot, like the XFS, ZFS. Lots of the DBA already using this sort of technology to do the backup, and we do as well because our storage provides this functionality. But this is definitely true for the large, like the 100 terabyte data. You never can consider that I can do a full backup and copy those data out. So the snapshot is very natural, like the truth. So we are going with that as well. And although our underneath is not really a file system, it's Azure storage, but we can leverage this sort of the functionality. And this is my last slide, which talking about the security enhancement. It's completely different when running some like the database engine in internet, like the world, and everybody come to the security, how they're solving that, and we try to give some of the answer here. One is that we say, okay, how about we support the virtual network, which basically says put all your related, like the VM or other database engine or web app inside the one virtual network, which basically lock down as another like your enterprise network inside the cloud. That's one way. And another is some enhancement we put into the MySQL engine is, today MySQL engine can authenticate one person with an IP address. But this is not really works in today's environment. Looking at how the firewall supported today in the OS, which is very, very like the suitable for today's world. So we're adding the similar support to the firewall, to the MySQL, try to lock down things. And also I want to call out is we do the lockdown. So this sort of the lockdown is because we're running in a SQL PAL. So we do lots of the lockdown. For example, we don't allow you to connect to external, which means even your database gets compromised, the hacker is very, very hard to use your database engine as a jump box to connect to some remote. We really lock down says you only be able to access the network resource you'll be allowed to access. So we even don't let you to make the outbound connection. So inbound connection, that's of course, that's what we're talking about here is we have a pod sharing service, which what that mean is we have a lot of the instance I already described that says inside one node. Like for MySQL, everybody will listen to different port. That will be a nightmare because you don't have a default port and you have a lot of the attack surface. So what we do is we have a service called a pod sharing service, which basically says, okay, this is the service this is the only service listen to inbound connection. So for this service, it's one port listened for each server. Like the MySQL has a 3306, and the SQL Server have yeah, I cannot remember exact number, but each server type. And there's a lot of the code we can add here to detect like the DOS, DDoS of things. And we're adding a lot of the telemetry here, which help us doing some threat detection things. But one of the important things is we can make sure that this code is really controlled by Microsoft, having our all security review process to make sure this code is really be locked down and secure. So that's one of the things here. And yeah, we also provide the encrypted at rest. As I already talked about a couple of times, the storage team is dedicated for storage. So they provide this functionality as it should be, right? There's no surprise they have this functionality. So this is pretty much, oh, last thing is the threat detection. So we already talked about the post sharing service, which writes lots of the telemetry. And then we're also adding the lots of the hooks inside the database engine itself, like the MySQL. And then we write out some telemetry, tell our backend AI system says, hey, how this database is using. Do you have a selector star to solve the query? If you don't have, suddenly you have one, we will think, hey, is somebody try to dump your database? So some of the things, we're adding a lot of hook there and try to write the telemetry, which helps the backend of the AI system to do the threat detection. So, okay, that's pretty much all I have. So, yeah, maybe I'll run a little bit quicker. I think there's lots of things I talked about. So any questions? Yeah. So today the encryption at rest is still using the key from Microsoft. And the storage team will roll out a new feature called the key vault storage. Like every customer can put its key into the key vault, and the individual blob can use that. That feature is in the plan, but didn't widely roll out. I think it's in the public preview some state. But I think after they really roll out, we will integrate that feature as well. Okay. Thanks. Yes?
Is there any plans to support like replicate sets so you can have more than one instance replicating with each other and this kind of thing?
Yes, that's on the plan, but for now I don't have much more to disclose yet. Okay. Yeah, that's my PM. He can talk about timeline, I cannot. Yes. Yep. Yes, we still have a local storage, but those storage is mainly for read-only cache. Yeah, I didn't mention that, but basically we built some functionality inside of MySQL. We call it the buffer pool extension, which basically uses my local attached SSD to be my much larger buffer pool. Otherwise, my latency kills me, right? This solves the local attached disk still existing, and we are leveraging that. Okay. Yeah. 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 Thanks. Okay. For debugger for what?
For SQL queries, for running out of space, some kind of.
I see. Yeah, I think we didn't do that, and we are largely expected the people still be able to use the community tool to do that, and because we didn't largely modify what the MySQL semantics. Most time it's inherit what the MySQL today. So I expect that most of the DBA should be able to use their existing tool, use existing knowledge to troubleshooting the MySQL on the Azure as well. Yeah, do you have answer?
I think the question was like you're running out of storage and I need to widen my storage.
Well, it's just everything, right? There's so many things to monitor.
Mm-hmm. see. Yeah, the space things would be. Okay. Yeah, I think probably.
I mean, the way we are looking at it is from the perspective of workload insights that Jun was talking about, where through AI algorithms, we would actually learn about the workload that's running and then suggest maybe you are missing an index or maybe you are going to run out of storage if you're in 5 days. Right? So yeah, so we're putting all those capabilities and then bundling into what we're calling as workload insights, which is actually current workload insights.
Workload insights, yeah. Yeah. Okay. So I have some like the Azure free credits I can give out, and you can use this to try our service and also other Azure services as well. So if you want, yeah, just go grab it. You want? Yeah, sure. Yeah, I still have a couple of that. So. Yeah. Yeah, there's some number in, oh, sorry. Some number in the back, which is, oh. Yeah. Oh, okay. Yeah. Oh, yeah. Thank you. Yeah, have a try, and, oh. Okay, thank you. Thank you, everyone. Yeah.